Good reason we may not remember a lot of algebra and solving for algebra. We may have had a long summer. We may have had several years between taking a class that required it. Maybe you're going back to school. Maybe you were in lockdown and you didn't learn too much or had trouble concentrating. And of course, we don't want to memorize. We want to understand how things work. So one very important concept in math that we learned was called Pemdas. The idea that you do the parentheses and exponents as a group from left to right, multiply then divide from left to right, either one, multiply or divide. Let's put an or. So it's not parentheses then exponent, it's either one from left to right when you're looking at the problem. And then last, we have add or subtract from left to right. So a lot of times we forget the or, and it usually won't matter, but every now and then it will change your answer. So what this means, we're going to use this concept for solving all the geometry solving, for the most part, that you need, all of the algebra required in geometry. So when you take 3 times 6 divided by 2, you'll ask, are there any parentheses or exponents? There are not. Is there any multiplying or dividing? And there's both. So we don't do multiplying and dividing next always. We go from left to right. So the first one on the left is the times, multiplying. So we do 3 times 6, it's 18. We copy everything else down. Then if there are more, we continue following the order of Pemdas, but there is only one left, the division. 18 divided by 2 is 9. We could have something a little bit more complicated. We could have 20 divided by 4 minus 10 minus 8. And it looks more complicated than it is. We ask, are there any parentheses or exponents? And there are parentheses. These are parentheses. So you do the innermost parentheses first and you copy everything else down. So 10 take away 8 is what's in the parentheses, that is 2. And we put that down there. We could put the parentheses if we wanted to. Now you ask again, is there any parentheses or exponent? And still another parentheses. So you'll copy everything else down and you'll do what's in the parentheses. 4 take away 2 is 2. And then lastly, you'll go to the next step. Is there any multiplying or dividing? And there is a division. So 20 divided by 2 is 10. So there is an order of operations that we follow called Pemdas. And again, we go from left to right, multiply or divide. Maybe you have 24 divided by 6 times 2. You don't do plus 3. You don't do the times first. You ask, are there any parentheses or exponents? No. Check. Are there any multiplying or dividing? And there are two. There is a division and a multiplying. So we go from left to right. We always go from left to right. We don't just do the multiplication one first. So from the left side, like you're reading, you always go from left to right. When you're reading a book in English, 24 divided by 6 we do first. 24 divided by 6 is 4. Then we copy everything else down. Now we ask again, is there any multiplying or dividing? There is. So we'll do the multiplying. 4 times 2 is 8. Copy everything else down. And we ask, is there any addition or subtraction? And that's the only thing left. So from left to right, you would do the addition or subtraction, which in this case is 11. So we did learn the order of operations, and most of us, we do that. We don't even think about it. But a lot of times we're not aware that solving algebra problems is doing Pemdas backwards. Any parentheses or exponent, multiplying or dividing, adding or subtracting. However, instead of from left to right, we're going to go from right to left when we're solving, because we're doing the opposite. We're not calculating a number, we're solving to get a missing number, a variable. So let's take a look at a basic couple examples of that. We'll have x plus 3 equals 10. We don't want to say, well, I know the answer is 7, because when it's a bigger, more complicated number, You might not be able to do that in your head. You want to know the process. So sometimes we'll put a line down the middle to remind us whatever you do on one side of the equal sign, you do the other. You always keep it balanced. These are like two sides of a scale that are balanced. So if I add a 2, I have to add it here. If I divide by 2, I have to do it to the other side. And we keep the scale balanced. So when I do a solving problem, which is what this is, solving for a variable, I'm going to calculate or look at Pemdas backwards. First asking, is there any addition or subtraction? And there is. There is a plus 3. So I'm going to do the opposite to both sides. We say minus 3. So we have to be familiar with our adding and subtracting of integers, positive and negative numbers. So the reason we did a minus 3 is because 3 minus 3 cancels. But whatever we did to one side, we had to do it to the other. So I'm going to copy everything else down. X equals 10 take away 3, which is 7. So we can do this with a little bit more involved here. So let's ask again, is there any adding or subtracting? We do that one first. We can draw our invisible line, and we don't do the multiplication first. We do the adding or subtracting. Then we do multiplying or dividing. So there is a plus 4. I'm going to do the opposite to both sides. Opposite of plus is minus. And I copy everything else down. 2x equals 18. 22 take away 4. So the 4 minus 4 cancels out. The whole point was to try to get rid of it. So we do the opposite so that it becomes 0. A lot of people forget that line. I mean, most of us don't draw it after a while. But sometimes when I see students make mistakes, they'll add to the same side instead of the other side of the equal sign. So if you need to draw the line, do that to help you at first until you get used to it. Now you ask, is there, and there's only one left, is there any multiplying or dividing? And there is. See, we may forget this. 2x means 2 times x. We don't have that times there. It's invisible. So we do the opposite. We always do opposites. Opposite of plus is minus, so opposite of times is to divide. A fraction is dividing. And we cancel that out that way. When you have times 2, you divide it by 2, it becomes 1. 1x equals 18 divided by 9, or 18 divided by 2, x equals 9. So let's try this idea. If you might want to take notes, when you're solving, you're going to do Pemdas backwards, from left to right. And I had a video about this. You can do even up to Algebra 2 problems using this same method because it's what we normally do as mathematicians. We just don't really talk about it in this way usually. Most of my teachers never really explain this directly. When you're calculating and adding and subtracting, you do Pemdas. When you're doing the opposite, when you're solving for a variable, you do it backwards. So I'm going to see, is there any addition or subtraction first? Then is there any multiplying or dividing? Then on the rare occasion in geometry, is there an exponent or parentheses? So let's try that with another problem. Let's do a division problem. So many people get freaked out when they see a fraction. It's not, in algebra, it's nothing really to worry too much about. So we'll take this, and you might say, well, what do I do first? We look at Pemdas backwards. Is there any addition or subtraction? There's a minus 3. So let's draw our invisible line. How do we get rid of the minus 3? We do the opposite, plus 3 to both sides. That cancels out. So I copy everything else down. Don't be lazy. Just copy it down and get used to writing every step. That's what we do to be careful. So 10 plus 3 is 13. So just like times 2x is 2 times x, x over 3 is a division, x divided by 3. And we didn't always talk about that directly. We kind of hope that you understand. A fraction is a division problem. So the opposite of dividing by 3 is we're going to multiply both sides by 3. And this cancels out. So x, or becomes 1, x equals 13 times 3, or 39. So as we get good at this, it becomes a lot easier to calculate or to do these solving problems, I mean. Again, we'll do Pemdas backwards from right to left. I'll do, I don't know, make it look weird. It's not really with a bigger number. So again, what will we do first? We're going to look for any addition or subtraction first. Then we'll ask if there's any multiplying or dividing, and then if there's any exponent or parentheses. So we see a minus, we will draw our invisible line, and then the opposite of minus 10 is to add 10 to both sides. That gets rid of it. So now we have x over 7, 12 plus 10 is 22. So again, if we could remember that that fraction is a division problem, we'll remember the opposite. We always deal with opposites. So the opposite of divided by 7 is to multiply by 7. So x will be, I believe, 154. Yes. So again, we can do the basic problems in solving this way always. Let me give you some more challenging ones that might have a parentheses or a hidden parentheses and an exponent. We don't use those as often, but just for those who already understand those basics. So what if I had something like this? So again, we'll still follow Pemdas backwards from right to left. And so what we'll do is we'll ask, is there any addition or subtraction? And there is here. So we're going to subtract by 5. If we need to, we could do our line. And we copy down everything else. X plus 3 over 4 equals 1. So this kind of has an invisible parentheses because this stuff on top is grouped together. So even though there isn't a parentheses, we're not going to do the addition or subtraction first here because this technically has an invisible parentheses. So when we look at it that way, we've already done the addition or subtraction. So now we need to ask, is there any multiplying or dividing? And the division sign, the fraction, is dividing. So we need to get rid of the 4 on the bottom before we work with what's on top because it's together on top, it's grouped. Parentheses group things together. So even though it's not written there, it's as if it's there. So we go with the 4. The opposite of dividing by 4 is to multiply both sides by 4. So you see when we multiply both sides, you kind of tend to put a parentheses there. So the 4 over 4 cancels and becomes 1. So we copy everything down. We get x plus 3 equals 4. And then we start over again. Do you have any addition or subtraction? You do. So we're going to subtract 3 on both sides. And x equals 1. So the few times we have an exponent, it will still work. So you may think you can't do this problem. Let's say 3x squared minus 3 equals 9, 27, let's say 24. Let's see if that comes out evenly, I hope. I'm going to ask, do I have any addition or subtraction? We're going to go PEMDAS from right to left. And I do, so I'm going to do the minus 3, and do the opposite of minus is plus. (3x squared) I'll copy down, equals 27. Now, do I have any multiplying or dividing now? And I do. I have 3 times x squared. Don't never forget that 3x squared is an invisible times. 3x means 3 times x. 3x squared means 3 times x squared. So we're going to do the opposite to both sides. Divide. A fraction is dividing, and that cancels out. So now I have x squared equals 9. So now I've done multiplying or dividing, and I ask, are there any parentheses or exponents? That's why we do the exponent last. We're following Pemdas backwards. So the exponent, x squared, we do the opposite of squared. And in my geometry class, we've kind of already mentioned the opposite of squared is, even the words in it, square root both sides. And we're always dealing with opposites and doing it to both sides. So when we do that in algebra, we'd get a plus or minus. Square root of 9 is 3 times 3 makes 9, so 3. In geometry, since we're dealing with real sides, we'll usually just use the positive amount because you can't have a negative side, or you can't be negative 6 feet tall. But this process will work with basically any algebra problem. We could even take one like this and see how this goes. So again, do we have PEMDAS? Do we have any addition or subtraction? And we have a minus 2, so we do that first. To both sides, we will do the opposite. 2 minus 2, or negative 2 plus 2, cancels. I copy everything else down. Then I ask, do I have any addition or subtraction left? No. Do I have any multiplying or dividing? So remember again that the fraction is a division sign. So the opposite of divided by 2 is times 2 to both sides. So that becomes 1. Cancels out. X squared equals 16. Do I have any more multiplying or dividing? We don't. So now I ask, do I have any parentheses or exponents? X squared is an exponent. So I will square root both sides because that's the opposite of squared. And I get plus or minus 4. So if you take time to watch this, take some notes, watch it a second time, you'll probably begin to understand the process that most mathematicians do just without thinking about it. I've been doing algebra my whole life, since high school, and until a few years ago I never really thought about which order we do it in. We just we know a certain way, and it's using Pemdas backwards. So Pemdas is super valuable not just for calculating, but Pemdas is very valuable for solving a problem as well. I'm hoping that helps to refresh your memory or give you a different understanding or perspective of why we follow a certain order of operations in algebra and what order that is. It's Pemdas from right to left, the opposite way from when we were calculating.